Yes, if I tell you to implement, how will you do? See, I have to get somewhere S and I have to get somewhere C at the output. Okay, so any function, it should give me this combination. So if I see S, what it has is X dash, Y dash, Z, X dash, Y, Z dash. Okay. And here pe X, Y, X, Z, Y, Z. Okay. So here you can think AND gate, AND gate, AND gate. Okay. X, Y, X, Z, Y, Z. You can use AND gate. And then if I'm using only two input AND or, okay, gates. So here I will require 3 AND gates, then I have to require 2 OR gates over here to get the function C. यहाँ पे हमें क्या करना है, X का complement, Y का complement, ANDing along with Z. Okay, and similarly ANDing over here, ANDing over here, ANDing over here, and then you will OR it. Now, what will be the usual logic is, what you do is, suppose you have taken X, okay, then immediately you give an inverter to it. This is idea I'm giving you. You will do the circuit. So यहाँ पे तुमको X dash मिल रहा है. ये line पे X है, यहाँ पे X dash है. Then the second input is Y. So let this line be Y, and immediately below it you have inverted it, so you get Y dash. When you take third input, wait, I'll draw it in a whiteboard. No, I'll draw it here only because I require the equation. So here suppose X है, तो एक line X का हो गया. उसके बाद immediately from it you do an inverter. Okay, connect an inverter, तो यहाँ तुमको X dash मिल गया. The next input Y, so you give it Y, और यहाँ पे Y dash मिल जाएगा तुम्हें. The third one is Z, so you take Z, and then this is Z dash, which you are getting. Okay, so because somewhere I require Z dash, somewhere Y dash, somewhere X dash. So all 6 combinations you have with yourself. Many times what students do is they write it this way. I'm telling you all the orientation. X, Y, Z इधर ऊपर से लिया. यहाँ पे मैंने horizontally लिया. यहाँ पे you can take vertically. ये X dash का line Y, and then here you can take it an inverter. Okay. Similarly यहाँ पे Y dash का inverter and यहाँ पे Z dash का. So all 6 lines you have over here. Okay, whichever way is comfortable, you can do it in this way. Either you take it over here and X idhar, X dash idhar, Y idhar, Y dash idhar. Then you start with any function. Like suppose carry पहले करना है. X into Y है. तो यहाँ पे X, Y का तो ले लो. ANDing करो दोनों को. Okay. So you have X, Y. Then you have X, Z. So यहाँ से इसको jumper, you show a jumper connection properly. So you have X, Z. So this is X, Y, X, Z. Similarly, you form Y, Z. Okay. And then what you can do is, I have to OR it. So ये दोनों को एक OR gate में दे दो और इसका आउटपुट दूसरे वाले के साथ OR gate में दे दो. Okay, so because I am using only 2 input, so first ORing with this 2 function, और इसका जो addition आएगा you OR it with the third वाला function. Okay, so this way you complete your carry. Then similarly on this side you can extend as a line लेके you can extend and you can make your circuit in a different part. So whole page you are utilizing for drawing the circuit. Okay, so this at least the approach is clear to you. Okay, so huh? Which one? This again I'll do it. Oh, see, I have to implement now this function using a circuit. Okay, so they have not specified right now NAND gate or NOR gate. Okay, that is the universal gate. So I can use general implementation is I will use 2 input gate only. Okay, or if they have not mentioned, I can use 3 input gate also. So what you will do is I have three inputs x, y, z, and if I see this function, I require complement also. So what you will do is, wait, let me write the function, then I can uh, use a simple whiteboard, not with this. I'll write it in another paper. So let me use okay. So what I will do is I take a function x, take a function y, I take a function z. So this is x. From here I give it to an inverter. So I have here x dash. y है, इसको invert किया, sorry invert किया, और ये है y dash. Z है, these three are my inputs. Okay. So I have z dash over here. So मेरे पास 6 lines है of my input. Then suppose carry जो सबसे easy है. What is carry? xy plus xz plus yz. So x into y. So what I do is I give it to an AND gate. X and y. So यहाँ पे मुझे मिला xy. Then I have xz. Okay, so I have another AND gate. So z दिया और यहाँ पे जंप कनेक्शन करके jumper. So here I get xz and the next one is yz. So y and from here a jumper. So this gives me yz. And then all these three are ORed together. So I connect an OR gate. So 3 input OR gate. Yes. So here I get my carry, which is xy plus xz plus yz. Yes. Is this clear? Oh, now what you will do is I have used my whiteboard just below this circuit. What you do now for S, I require x dash, y dash, z. So from your x dash line, I'm just showing you x dash. So you will show a jumper. ताकि वो connection नहीं रहे ऐसा jumper. You give it to again an AND gate. So x dash, then you have y dash, and the z is over here. So यहाँ पे तुम्हारा आया x dash, y dash, z. So similarly, you have 4 3-input AND gates. So next AND gate में you give. So this line, no, Glenn, when you are drawing this line, ये line काफी बड़ा लेना. Okay. So you can use the page either horizontally, otherwise circuit काफी बड़ा रहेगा. Okay. हाँ, because and you do this jumper connection. Jumper अगर नहीं किया तो लगेगा वहाँ से ले लिया. If it is a straight line. Okay. And जहाँ से connection start करेंगे वहाँ पे कैसा connector मतलब वो जब node थोड़ा दिखना चाहिए. So you have then इसके नीचे then you have 4 AND gate giving you x dash, y dash, z. The next one again you take. So only thing is you have to remember जहाँ 6 combinations है 6 में से कौन सा तुम्हें चाहिए. So you see your function and you take that combination. And then at the output again you have an OR gate. Okay, so you can take 4 input OR gate and then you get the final sum. Now see, if suppose they tell you use only 2 input or 2 input AND gate, तो तुम क्या करना, जैसे suppose I will show you from here this part. So अगर सिर्फ 2 input है अब, so then what you do is you take this 2. Okay, you give it to a 2 input OR gate you give it over here and you take another OR gate over here और ये वाला input इधर दे देना. Okay, so it is one and the same thing. If nothing is specified, don't worry. Take 3 input से ज़्यादा तो तुम्हें variable देंगे नहीं. So you can take 3 input, 4 input, all good. Okay. Okay, so it's clear now. Yeah. Okay. Now, continuing with this. Now see, here they have reduced the circuit. वो मैंने तुमको बोला था कि with at OR gate, AND gate or NOT gate. Now here they have used an XOR gate. Okay, so that will still reduce your circuit. So do this one, draw this one. So here you can see X, Y. So X, Y यहाँ पे देंगे तो तुम्हारा यहाँ पे X dash Y, ये देखो यहाँ पे है तुम्हारा X dash Y plus X Y dash. Here you can see, no? The second function, see the pointer, and the third function. Here you can see, no? X dash, just a moment. This two. X dash Y and X Y dash है ये function में. Okay, and Z dash is common, ANDed with Z dash. ये वाले में. Okay, so X and Y, you can give it to an XOR gate. Okay, so here you have X dash Y plus X Y dash. So after every gate, you write down the function. Like suppose you take gate, you give the number 1, 2, 3, 4, 5. After every IC, you write what will be the equation that is coming. You have written output of gate number 4. Gate number 4 का क्या आएगा? See, when you find out output of gate number 3, at that time what you can do, you can take this as some capital A, this whole expression, because this is again an XOR gate. So your sum will be A dash Z plus Z A dash. Okay, here Z is going, no, from here Z is going. And this whole input, suppose you're taking it as A, any letter you take apart from X, Y, Z. So suppose I have taken capital A. So A dash Z plus Z A dash. Then you substitute the value of A. So A is then your X dash Y plus X Y dash Z. And then, so once you expand this, you get the full equation.
Full equation, yeah. X dash y dash plus x dash y dash y z dash plus x y dash z dash plus equation
This is A dash Z plus, sorry,
z
एक मिनट हाँ. A dash Z plus
z y and your x is coming
A Z dash.
y z
So यहाँ पे Z dash है हाँ.
and this one and
ये whole law है.
here is coming x dash y x comma y.
So you should be getting this particular output.
This one.
So this is your full adder circuit using your AND gate, OR gate and your XOR gate.
So this one.
Now suppose if I tell you, this is one more question that comes in the exam, the way implementation of full adder using half adder circuit. Okay, so we have studied now half adder, we have studied now full adder. So you already know your circuit of half adder, so they tell you implement full adder using half adder. So if I have to implement this one, full adder using half adder, so though half will make one full, yeah? So two half adder and then I require an OR gate to implement the full adder circuit. So this is your block diagram, you can say. So the first half adder, what I'm doing is I'm giving two input. Half adder has two inputs. So I give A, B as input and then C is my output and I have the sum and the carry. So the full adder has three inputs. So what I do is I give it to a second half adder. So the second half adder, my input is the sum of the previous half adder over here. And I give the third input as C. My final input in full adder is A, B and C. So the sum of the previous half adder is my second input and your C is my the second input of the second half adder. So here this way sum. So ये sum में क्या आ गया? पहले दो half adder का, that is A plus B, और अभी A plus B plus C आ जाएगा. So I get the sum. And how I will get the final carry? Carry of the previous one plus carry of the current one. If I OR it, I get the final carry. So this way you can implement full adder using two half adder and then OR gate. So again draw this block diagram. Glenn, in your just a moment, wait, I'll stop recording this, pause recording.
What will be the question for DSD?
First two chapters. So whatever we did, try to follow that only. Little bit changes I will do here and there.
Okay.
Okay, so you have drawn this? No?
Yeah.
Now see, implementation of full adder circuit using NAND gate. The previous one was very simple, XOR gate, one AND gate and one OR gate was there. Now suppose they tell you using only NAND gate. So this is the circuit. I'll upload this PPT in Moodle. At that time you do it. Okay, right now don't copy. Okay, and when you are copying it, but you do it. Okay, and then you will write output of after every IC. Otherwise, it is meaningless. So what you will do, you will give a name 1, 2, 3, 4. That is how we do also in the lab when you implement the connection.
Okay.
Okay, so you write down what is the output of after every IC over here, so that to get the final answer, it becomes easy. So similarly,
Okay.
you have the full adder circuit using your NOR gate.
Okay.
So, you require total 9 NOR gates to get the full adder circuit. So again the same thing, but again the circuit is very big. So mostly in exam they will not tell you for full adder because the circuit is big. They will, but you have to remember this particular step, the easy one. Okay, so now we go for a subtractor circuit. So a subtractor circuit is a digital circuit which performs the subtraction operation. So again, we will be doing half subtractor where we will take 2 inputs, and then a full subtractor where we have 3 inputs. So half subtractor, it is a combinational circuit, and see all these circuits that we are studying right now, adder, subtractor, half adder, full adder, they are all called as combinational circuit. Why combinational? Because we are using various combinations of AND gate, OR gate, NOR gate, NAND gate, XOR gate, and then we are getting the final answer. So that's why combinational circuit, combination of the simple gates. Okay, so those circuits, if you might see the chapter, the name might be combinational circuits. Okay, so here the half subtractor, it performs subtraction of 2 binary bits. So anything with half is related to 2 and full means 3. Now in addition, we had sum and carry. For subtraction, the 2 inputs are minand and subtrahend, and the 2 outputs will be when I am subtracting, so it is the difference, or if my subtrahend is small, I have to borrow. Okay, so here the 2 outputs will be difference and borrow. Okay, so this is the truth table again. So you draw the truth table. So we have 0, 0, 0, 1, 1, 0, 1, 1. First understand this, then you draw. So I have the half subtractor. So I have the difference and I have the borrow. So 0 minus 0 is 0. Okay. Now when I want to do 0 minus 1, I cannot subtract 1 from 0. Okay. So what I have to do? I have to take a borrow. Okay. But 0 minus 1 as such the difference will be 1. I यहाँ पे borrow किया तो वो 1 minus 1 0 नहीं हो जाएगा. But since I cannot subtract 0 minus 1, I take a borrow, but my difference is 1. Then 1 minus 0 is 1.
Is 1, yeah.
And there is no borrow.
Nothing.
Nothing. And then 1 minus 1 is 0.
0.
Okay, so I get a borrow only in this case when I am subtracting 1 from 0. So I get a borrow from here. So this is the truth table of your half subtractor circuit. So this is, we are simply using the rules of our binary subtraction which we did in chapter 2, I think. We did the binary addition and subtraction and then using 1's complement, 2's complement. So same thing we are doing. So this is the truth table for the half subtractor circuit. Now what you will do? Again, now I expect you to do, again you will make the truth table. From the truth table you will draw the K map and try to find out the equation for difference, equation for borrow. So again, after drawing this, again you will make table. So 0, 1, 0, 1. A oblique B. Okay, so we can take oblique B. So 0, 0. Suppose I am drawing for difference. 0, 0 is 0 over here. 0, 1 is 1. 1, 0 is 1. And so here this is separate, this is separate. So you get the function for D. Similarly for borrow, there is only 1 that is present. Okay, so 0, 1, 0, 1. So at 0, 1 combination, I have 1, rest all are 0. only this combination. So this is my borrow ka output. This is my difference ka output. So write down that equation. Give the heading half subtractor circuit and also mark it. It is a combinational circuit. So your difference function, are you getting this?
Yeah, 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 yeah.
So here you have, for this one you have a dash b, and for this one you have a b dash. This is your difference equation, and here you have borrow equation. Only one term is present, so that is a dash b. So this is your A map simplification for half subtractors. Now, if I tell you circuit diagram, you finished with this?
Yes, I'm done. Yeah, yeah,
Okay. Now the circuit diagram.
yeah.
It's not it. So this is B over here. This is A dash, not it. So my borrow is your A dash B. So it is going to an AND gate. And the difference, if you see the equation, the previous one, what was the difference equation? A dash B. So I give it to an XOR gate. So I get A dash B plus A B dash. So you can see by using this XOR gate, many of our things are simplified.
Yeah, so easy.
Mm.
Yes, I'm done.
Now this is implementation of half subtractor using NAND gate. So you quickly draw this one. This will be similarly half subtractor using NOR gate, which you can draw it later on from the PPT. Okay, so here also 5 NOR gates are required. Here also 5 NAND gates per there. Now comes the last of this topic is full subtractor circuit. So here again, full subtractor, what is the differences? We have total 3 inputs. So here they are saying that is the 2 original bit, and third one is the borrow from the previous stage. Okay, so in a combinational circuit, there might be the next stage, or for the next stage, the first one might be the previous stage. So the first 2 bits, we call it as the original bit, and the third input, C, I can call it as a borrow from the previous stage. And again here I get only 2 outputs. So difference and the output is borrow. Okay. So if I see the truth table, now see here the truth table, what I am not writing as C. Okay, so what I am doing is AB is my regular 2 input, and the third input is the borrow from the previous step, because since I am subtracting I need a borrow. But that does not make any difference. Okay, so यहाँ पे A, B, C के जगह पे I am writing B in. So here you write down B in is borrow of the previous step, and then again I have difference in a subtractor circuit, and I have borrow B out. Okay, so again you write down this, so 2 raised to 3, so 8 combination will be there. Then the difference and then the borrow. And try to understand how you are getting the difference. See, 0 minus 0, I'll explain 2, 3. 0 minus 0 is 0, all are 0. 0 minus 0 is 0. But 0 minus 1, I cannot do. I require a borrow in that. So that's why the borrow is 1 and the difference is 0. Yahan pe bhi, third case, 0 minus 1, I cannot do. So I require a borrow. Okay, so I have 1. And then again 1 minus 0 is 1. So that's why the difference is 1. यहाँ पे 0 minus 1 again I cannot do, so I am taking a borrow, and then 1 minus 1 is 0. So this is how you will make the truth table. So complete that. Understand and then complete the truth table. If this session ends, we will see the circuit diagram tomorrow. So today you complete the truth table, and then we will see the K-map.
Okay. Yes, ma'am. Done.
With the truth table.
Yeah, yeah.
Oh, now the K-map. Can you try?
Yes, ma'am.
So here, what you will do is, so 3 input will be there. So what you want to do is, whichever way actually, wait, let me raise it. So here you can take 2 on this side, 4 on this side, whichever way is comfortable. So you have A, B and B. That way also you can do. So 0, 0, 0, 1, 1, 1, 1, 0 and 0, 1. Fine, answer will be the same. So 0 completed. Try to get the equation for both difference as well as borrow. You get it. Then just see when you are doing the K map. Okay, suppose you have this type of shape. यहाँ पे एक वन है, इधर एक वन है, इधर एक वन है, इधर एक वन है. It is alternating in one row, then the second row. Okay, second row, second column, again second row, third column. This is second row, first column. Okay, first row, second column. Again second row, third column. This way अगर ऐसा जाता है तो it is directly an XOR function. Okay, so तीन input है. Okay, so you will solve it if you want. Okay, but I'm telling you the pattern which also comes in K map. कि तीन input है and if you have this alternate ऊपर नीचे ऊपर नीचे zigzag जा रहा है. Okay, this way if it is going. ऐसा 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 जा रहा है. So it is your three input XOR together. So your answer will be A XOR B XOR B. Okay. Otherwise you will spend time. या इसको क्या लिखोगे? A B dash B in. Okay. Then this will be A dash B dash B in. Okay. So then again you have to take a common. Here they have taken common. It's only two more steps. But then finally you remember your answer will be the XOR of all the three kinds of inputs that you have taken. So you have A XOR B XOR B in. So this was the K map for the difference. Similarly, you have for the B out. So if you have entered over here, so this two function they have mapped, and this middle one they have mapped. So yeah, so the P out comes out to be this equation. So we will be ending with the K map simplification of B out and difference, and then tomorrow, because again the circuit will be big, so tomorrow we will again see the circuit. So you write down